Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. Before continuing on the topic today, I just want to acknowledge a small thing. I had put a small video on D-long, calculation of difference of longitude, just 2 days back. And I could see the trend normally within 24 hours. I don't get so many hits of views within 24 hours. I could see that, which evidently means that the topic was a good one and a lot of people had doubt on that. So that is my conclusion. But anyway, as far as it helps you, and that is what is your the purpose or my aim also and your purpose. And still, as I've been telling earlier also, feel free to comment in case you have any queries. If I find any topic which is worthwhile, which could be as small as this D-long, but if it clarifies a lot of basics, I can do a video on that also. So feel free to keep in touch. You can comment. I'm not looking for a lot of likes the way people do. That is not my intention. But if you feel that you have something to share or you have some query, you can always do that. That freedom, yes, we have. I will surely try to answer your queries also. So without wasting time, let us go to the next topic on the same series. Going to talk about distance and directions in continuation with whatever we have done till now. Let me start with distance, and one of the most important distance for you to understand and learn is your nautical mile. Let us define nautical mile. I'll show you as usual with the picture. The definition might look a little bit long, but doesn't matter. The moment I show you the diagram, I think it will be easy. Now, please look at a couple of things here. He talks about center of curvature. I'm going to read it out. It's length of arc of the meridian. We have been looking at this definition of arc of meridian, which relates to a latitude. And he's given you a particular angle. He says that angle is only 1 minute at the center of curvature of that place. So just to go back into the history, this is related to geographic latitude and the vertical principle. We have already seen the vertical principle. I'm going to redraw that. Let me just quickly show you this definition. I'm showing you a kind of spheroid, a man standing here. If I draw the vertical, this is the center of curvature for that particular place. Now he says that if I draw one more vertical, which is just 1 minute away from this particular place, so that means I'm drawing one more vertical, which is just 1 minute away from this place, then I can measure a small arc of the meridian where he is standing. So this is the arc of the meridian. And this arc of the meridian is basically called 1 nautical mile. So you can see alpha is a d-lat of 1 minute, difference of latitude of 1 minute. Hence the arc subtended on the earth will be 1 nautical mile. So this is what is the definition of a nautical mile. But there's a catch here. Please remember spheroid. The word spheroid means the curvature is not constant. And we have already seen this. Earth is bulged at the equator and flat at the poles. So what is the problem? Let us just quickly see what is the result of this. Okay. So what happens is when the curvature is not there, not same, the person standing at different places on the earth will have different center of curvatures. So I'm going to show you one more place. What is the end result of this? This means the angle can be still 1 minute, but the arc subtended because of the change of curvature will be different. So I'm going to show you one more place near the poles. Let us call the first one was near the equator. The second man is somewhere near the poles. This is the vertical center of curvature, subtending an angle of just same 1 minute. And I got one more vertical, but this time this arc is going to be more than what we saw near the equator. So what is the conclusion? Again, Earth is bulged at the equator and flat at the poles. So at poles, this arc, which I have just drawn, when it is measured, it comes as 1861.7 meters. But at the equator, the first diagram, the first person, it comes as 1842.9. So what they do is they take a mean or average, and this is what is important for you to remember is 1 nautical mile is 1852.3 meters. So remember this in future, everywhere you're going to use this one figure. Okay? So I'll just quickly go back to it, 1852.3. So this, as a navigator, you should not forget. When you keep using it, you'll remember something important. Let us look at something called knot. Okay. Knot has got a history, so I'm not going to go to the history. This was in olden days, they used to use a rope with knots to measure the distance traveled in some time. But we have modified it and started using in the modern days. It is simply the number of nautical miles traveled only in 1 hour. Now, this is something the beginners sometimes I've seen management students also doing a lot of mistake. I know it is not deliberate, but it's oversight. You cannot call it a knot if the distance is done for even 59 minutes or 61 minutes also. No, it's called a knot only for 60 minutes, which is 1 hour. Okay. Let's look at one more definition, which is called geographical mile. Again, I'm going to show you the picture. This time, I'm using a different principle altogether. In the last definition of nautical mile, we were using more of definition of a latitude actually. Now I'm going to use the definition which is very similar to a longitude. So it is the length of arc of equator. So if you remember, when we talked about longitude definition, one of the part of definitions arc of the equator. Now, how much is this length of arc for? It is for an angle of 1 minute. Where is it subtended? It is at the center of the Earth. So I'm going to show you. As I said, it is somewhat related to longitude. So I can call it, it is length of arc of 1 minute of d long. So I'm going to show you this. So let us take this. I call this a center of the Earth. Just with a depth, we don't have a three-dimensional view. So I'm taking one point, and this will have a meridian. You'll have one more point. I will have a meridian for that also. And this angle, what is subtended at the Earth is 1 minute. Okay, it's 1 minute of d long. So theta is 1 minute. And this is the arc. So this one arc, this arc is called one geographical. So this is constant. Why? Because when you go along the equator, the curvature is considered constant. So it is a horizontal distance measured by equator, and it's a fixed value called 1855.3 meters. Remember, that was 1852 and this is 1855. So remember, this is not much used, but nautical mile is always used. Okay. Two more definitions of distance are there, which is very not very important, but it's worth to know. Statute mile, it is nothing but a land mile. If you remember, in athletics, one land mile is 1,600 meters. It is not 1,852, it is 1,600. Then the last one is a kilometer. I'll just try to explain a kilometer by diagram. It is basically called 1 by 10,000 of the total distance measured from equator to the poles on your meridian. Okay, I'm going to show you that picture. So what we do is we measure the distance along any meridian from equator to pole like this. So equator to pole is 90 degree, and this is the measurement you do. When you do it, you can calculate actually. It's 90 degrees. Each degree is 60 minutes. Each nautical mile is 18523. Put it in kilometer. So you get around 10,000, a few odd kilometers. So approximately what you do is you divide by 10,000, and that is what is called a kilometer. There's no need for you to remember these two definitions, but there's nothing wrong as a general knowledge to know it. I'm going to go to directions. Before I go to the actual definition, I want to show you what is the difference between a global and a local direction. Let me show you a global. I'm showing you the Earth. Let us say I had a start point called A and an end point called D. If I travel like this, please remember, I'm very evidently showing you that I'm traveled northwest. I can prove that by D-lat and D-long also. It is north and west. So this is called a global direction. Why? Because it's on a large scale basis. But in real life, you cannot do a straight line course from A to B. Okay. So I'm again showing you A to B. And this is a global direction. In real life, you will not do it. When you are sailing, you are going to do multiple courses. So I have a local direction westerly, northwesterly, southwesterly, southerly, and westerly, and then again northwesterly. And then finally I reach this place. So I'm interested in this local direction. Why? Because this is where I'll be changing my course regularly. So I'm going to talk about the local direction. So let us go for the local directions. Okay. Direction, in other words, can be related to azimuth also. Azimuth is something you measure horizontally around you, which is local. And the direction, if it is showing you your heading, okay, or the course you are following. See, heading is something which can be static also, but course is something when we are moving, okay, or the track. So usually is referred to the fore and aft line of the ship. It's very important. It's fore and aft line of the ship. Okay. So how do I measure? The first most important measurement is true directions. Okay, local, but they are true. So we are always going to reference this true direction with a 0. And for me, 0 for an azimuth is always true north, which is geographical north, which is your north pole or your own meridian, because every meridian goes to the north. So I always call it true north. This is the meridian if you want to imagine. It is denoted by 360-degree format. Is always 360. If you don't have any digit, you should put 0 on there. Okay, you just remember. I'll show you that. Let us say this is your fore and aft line. Okay. I'm going to explain about true course and true heading also a little bit later. But right now, I'm just trying to give you a gist of it. So I can call this 045 degrees. And let us say my vessel was like this. I can, for example, call this 290 degrees also. Bracket T. Please remember bracket T. So true north being 000 degree true, and all measurements are taken clockwise from 0 to 359. So 360 is again your 0. There is one more very important way of depiction of direction, which is called quadrantal directions. Why? Because as I told you, whatever I'm teaching is finally going to lead towards day's work, and day's work is worked on quadrantal course. So true direction can be depicted in one more popular format. 360 degrees is divided into 4 quadrants. So that means an angle cannot be more than 90. Okay. So let us see how to do that. I'm going to give you the same example of 045 and 290. I'm going to show you in a quadrantal direction. Here, a catch is there. Angles cannot be more than 90. So angles have to be always measured starting from either north or south only. And then you should go to east or west. So that is why priority is north and south, and secondary is east and west. So if you look at 045, it will be somewhere here approximately. Don't go by actual picture, just approximate. I can go from north towards east. So I call it north 45 east. Here, please remember there is only 2 digit of an angle. Why? Because the numbers cannot be more than 90. So there is no question of adding 0. It is not there. Okay. I'm going to show you what is 290. Again, always going from either north or south. The closest is north. So it is called north 70 west. I'm going to give you just two more questions and let us solve this 150 and 220. So 150, you know it is on the southeasterly quadrant, but angle has to be measured always from south. So it will be called as south 30 east. What about 220? It is here measured only from south and it is called south 40 west. So this is how you do a quadrantal direction, extensively used in your day's work, plain sailing, and your marketer sailing. I'm going to define this true course and bearing now. We have already seen a small gist of this. What do you mean by true heading or a course? As I said, heading can be static, course is dynamic when you are moving. It is the angle measured at the vessel. That means this is the vessel. It is measured at the vessel in a clockwise direction, from true north to the fore and aft line of the ship, and that is what is 045. Then what is true bearing? Please remember, bearing is of any other object, around you. So I'm going to give you a small, let us say, a lighthouse. So what is true bearing? Again, angle measured at the vessel in clockwise direction from the true north to the line joining your vessel and that object. So I can give you an answer for this also. This is 120. Let me show you one more lighthouse. So again, same thing. Angle is measured at the vessel going in clockwise from 000 to the line joining vessel and the object. So this is 290. Now I'm going to give you one last definition for today, and that is called relative bearing. For the same example, just the same example, what we have done in these two lighthouses, I'm going to use it in relative bearing. Relative bearing is, again, an angle measured at the vessel only, again clockwise, but this time we don't start from 000. We start from the vessel's heading, which is already 045. And from there, I go clockwise till the line joining the vessel. So this is what it is. So the previous example can be written as 075 relative. This is how it is written. I'm going to give you the second lighthouse. Here, again, you will measure the angle at the vessel clockwise from your vessel's heading, and the answer will be 245 relative. These were the same two lighthouses which were there in your previous diagram. Angles in relatives are always measured with 000 relative to 359 relative. Your 000 relative is your vessel's heading. So just keep that in mind, because relative bearings can be given to you in your chart work problem. It can be given to you in your radar plotting and all those problems also. So you should be able to use it. Okay, that's it for today. I hope it was simple to understand. I'll catch you soon, and keep watching Jal Prayag, and feel free to ask any doubts or queries or comments. Until then, Vanakkam, Namaste, Namaskar.